Welcome to today's Explainer. We've got a truly fascinating topic lined up for you today, one that starts with rocks and somehow ends up in 19th century philosophy. Our Explainer is titled, How Does a Geologist Decide? John Henry Newman's Elective Sense in Economic Geology and Mining. Today, we're going to bridge the gap between the incredibly high-stakes, nerve-wracking world of mineral exploration and some seriously deep epistemological philosophy. It's all about how the human mind takes a bunch of scattered, messy clues and turns them into absolute, unshakable conviction. So I want you to imagine the visceral tension of this scenario for a second. You're a geologist. You are standing right in front of a board of corporate investors. Spread out on the table before you is a geological map, maybe a structural map, a handful of scattered geochemical anomalies, and a few signs of promising hydrothermal alteration. That's it. It's a puzzle with half the pieces missing, and those investors are looking you dead in the eye, asking the literal million-dollar question. Does this project have real potential? Is this the exact target where we should sink a diamond drill hole that's going to cost hundreds of thousands of dollars? You have to make a choice. Drill or walk away. All right, let's map out our agenda for this explainer. First, we'll look at the million-dollar choice, then define the elective sense. After that, we'll compare book models versus field reality, explore the value of failure, push into the AI frontier, and finally wrap up with teaching intuition. Okay, kicking things off with Section 1, the million-dollar choice.
Here is the absolute crux of the problem. From a purely mathematical standpoint, an honest geologist might want to give a probabilistic answer, right? They might want to say, well, there's a pretty high statistical probability of success, but it's definitely not a guarantee. But you can't do that. Corporate decisions in economic geology cannot be made on probabilities alone. The decision is entirely binary. It is 100% yes or 100% no. You either sign that massive check and order the drilling, or you walk away entirely. You literally cannot drill a hole partially. So despite having totally incomplete data, the geologist has to commit fully. There is no room for mere mathematical probabilities. The real question is, how does the human mind leap from incomplete data to an absolute conviction that drives action?
That brings us right to Section 2, defining the elective sense. To find this missing link, the thing that explains how our minds reach total conviction, we aren't going to look at modern algorithms. Actually, we're going all the way back to the year 1870. The man who holds the key here is a 19th century thinker and theologian John Henry Newman. In his masterpiece of epistemology, An Essay in Aid of a Grammar of Assent, Newman totally obsessed over how human beings reach practical certainties in a messy, non-deterministic world. He realized pretty quickly that formal textbook logic falls completely short in daily life, especially in field sciences. We simply don't wait for 100% indisputable proof to make huge decisions. Newman proposed that humans possess a very specific natural faculty, which he called the elective sense. Pay close attention to this because it's absolutely crucial. He defined it as the mental faculty required to judge the validity of an inference in concrete matters by integrating a set of clues, evidence, or convergent reasons to achieve practical certainties beyond the limits of verbal logic. So what does that mean in plain English? It's our organic, often completely unconscious ability to weigh a massive accumulation of converging clues. No single clue is irrefutable proof on its own, but when they all start pointing the exact same way, our elective sense steps in and unifies the puzzle. Newman divided the way we agree with something, our assent, into two distinct categories. On the left, we have notional assent. This is passive. It's the acceptance of abstract theories, formulas, and textbook definitions. It's like memorizing what a porphyry deposit should look like on paper. But on the right, we have real assent. Now this is conviction about unique, physical, concrete realities in the real world. It's the absolute bone-deep certainty that this specific hill right in front of you hides mineral wealth. And that elective sense we just defined, that is the exact engine that drives us from notional to real assent. Moving on to Section 3, book models versus field reality. Consider the profound epistemological gap that a novice faces out there. When a young geologist steps into the field for the very first time, they are operating purely on notional assent. They look at a real geological outcrop, and what do they see? It's weathered, it's covered in vegetation, chaotically fractured, and totally distorted by millions of years of overlapping processes. The textbook formulas completely failed them, and they experience what you might call interpretive paralysis. But the veteran expert? They've developed what the industry calls the geological eye. They don't try to force the messy rock into a neat textbook definition. Instead, their elective sense instantly evaluates thousands of microclues. A subtle color change in the soil, the way moisture sits in a tiny fracture, the specific resistance of the rock when they strike it with a hammer. They instantly read the terrain and achieve that real assent. To really wrap our heads around the power of this mental leap, let's look at a universal human decision: choosing a spouse. Think about it. Nobody decides to get married based on a cold statistical calculation. If you only looked at divorce rates logically, you would conclude that marriage is an unacceptable risk. But when you know someone is the one, your mind has internally processed thousands of unquantifiable microprompts. Little gestures of loyalty, shared values, specific looks across a room. You integrate all of these to generate a 100% real assent. You commit fully. And believe it or not, this is exactly the same mental architecture the geologist uses to say, we must drill here. Now, the real world is incredibly unforgiving, which brings us to Section 4, the value of failure. What happens to this absolute certainty when a multi-million-dollar drill hole comes up completely, totally empty? Does a negative drill hole mean the expert's initial certainty was just some irrational illusion? Absolutely not. Newman made a really brilliant distinction here between certainty and infallibility. Certainty is a state of mind regarding a specific case based on the available evidence. Infallibility is the impossible trait of literally never being wrong. And guess what? We are human. We are not infallible. When the drill hits nothing, a true expert doesn't cling to the failed target out of pride or the sunk cost fallacy. Instead, they treat this failure as extremely high-value data. The sheer human shock of reality provides a crucial new data point that physically refines and immediately updates their illative sense for the very next attempt. Let's transition to Section 5, the AI frontier. This builds into the ultimate modern showdown, the seasoned human field geologist versus artificial intelligence. The crucial point here is that while AI and machine learning algorithms can process millions of geochemical data points at lightning speed, they are purely notional. They operate entirely on syntax, not semantics. An AI might output an 87% probability of a fault existing. Okay, sure, but that's just a conditional statistic. The AI lacks corporality. It literally doesn't have a body. It doesn't physically hit the rock with a hammer. It doesn't feel the physical exhaustion of the climb, and it cannot take an existential corporate risk with intimate conviction. When an algorithm fails, a screen just recalculates. When a human fails, they experience the shock of reality, which matures their professional judgment. It's the human geologist's alliterative sense that takes that 87% probability and makes the absolute practical leap to 100% certainty.
And finally, Section 6, teaching intuition.
We've seen that the geological eye isn't some mystical superpower. It's the empirical manifestation of Newman's elative sense. So, as we wrap up this explainer, I want to leave you with this final provocative question. Think deeply about this. If the elative sense depends strictly on embodied experience, accumulated habit, and the human shock of technical failure, is it methodologically viable to design university curricula that accelerate the development of this intuitive expert judgment in students before they face the field alone? How do we teach that leap from textbook theory to real-world conviction? It's an immense challenge, but it's one we absolutely have to face. Thanks for joining me on this explainer today, and keep questioning how you reach your own certainties.